안녕하세요. EQ4All AI 연구원 매튜입니다. 자료는 한국어로 준비했는데 그 답변은 영어로 진행되는 점 이해 부탁드립니다. 일단 우리가 Sign Language Avatar 회사 sorry. We are a sign language avatar company. You can see two of our avatar samples here up front. I prepared this speech to be more general than technical, but while we go along, if you have any technical questions or at the end, feel free to ask me. I'm going to go ahead and start with a introduction to our company and give you a sample of one of the projects that we've done. This is a project we did with SRT. You can see our avatar here. This is actually one of our employees, one of our deaf employees.
안내 말씀드립니다. 지금 우리 열차 5호차, 6호차에 발생한 화재로 인해 비상정차하였습니다. 승객 여러분들께서는 동요하지 마시고
So the important point here is that something happened to the train, but they make an audio announcement to let everyone know what happened. Unfortunately, if you're deaf, you can't hear that. And some people suggest using maybe speech-to-text solutions to give a text announcement for deaf people, but as we heard in the first speech today, many deaf people have difficulty understanding Korean. So the solution that we're proposing is an automatic sign language translation. We actually install a device inside the train which will convert Korean to Korean text, and then we can translate it automatically using our avatar technology. So I'm going to talk a little bit more about sign language. We already heard a little bit about it in our second presentation, especially these first 2 points. This is the biggest misunderstanding about sign language is people think it's a constructed language, or all around the world people use the same sign language. But no, sign language has a normal history just like any other spoken language. This is an important date in sign language history in Korea because on this date, sign language, Korean Sign Language became the official language of Korean deaf people. And finally, I want to talk a little bit about how sign language has this multimodal and multidimensional aspect. So multimodal, what do I mean by that? I mean that unlike spoken language, which is only delivered with sound, sign language is delivered with 2 hands. You can also express things with your face, with your head, and with your body. We call these things that aren't expressed with your hands non-manual signals. So in Korean, 비수지, we say. Can I ask, are people mostly familiar with sign language that are here? Or, does anyone actually know sign language? No? Well, then it's good. We can review these types of things. So an example of multimodalness, one situation, we've been doing a couple of projects with emergency alert messages, so 재난 안전 문자. So one example that we'll have is there's a fire at some location. So we have to tell people, don't drive by that location, take a detour around. So in sign language, we can express this using both of our hands. I'll give you an example. So fire, the sign for fire is this. The sign for car is this. Okay, so we can use both of our hands to express this at the same time. So we can say, at some location, there's a fire. So people that are driving, take a detour. So simply using these different aspects of our body, we can express this message in sign language. And that also shows the multidimensional aspect as well, because we're expressing multiple signs at the same time. Another example for bisuji that I want to give you. This sign by itself, just doing this by your face, doesn't actually mean anything. But if you combine it with different bisuji, you can change the meaning and actually make it mean something. So, like this type of expression means 신기해, 신기하다. So something's interesting. This means something's weird, right? So it's actually 이상하다, very different meaning. And so something that a lot of my deaf friends actually do is instead of using it with their face, they point to something. Usually they point to a person to make fun of the person, but you can point to maybe a computer. And if you want to say this computer is acting strangely, I can do this. So sign language is a very flexible, dynamic language system. As I mentioned, 이수지, 양손수화, so using both of your hands and using your face. Another point that's also important that I want to add is called chiwa, finger spelling. Is anyone familiar with finger spelling? Chiwa? It's okay. So sign language has an interesting thing where you can borrow words from any other language, basically, just by spelling out the word with your hands. So for example, my name Matthew is spelled M-A-T-H-E-W. So basically, you can just borrow words from any language. And sign language uses a lot of this finger spelling. Korean Sign Language, American Sign Language, most sign languages actually rely on this heavily. And so I'll show you an example in a second of a native signer using Chiwa and using all these other characteristics. So this person is explaining about this is a roof tile from Chindo, and she's going to explain a little bit about the history. I want you to notice the first thing that she did is spell out Chindo, because most people probably aren't familiar with the sign for Chindo. So first she signs it out so everyone knows what she's talking about, and then she'll show you the sign. And in the future, she won't sign at all. She'll just she won't finger spell for Chindo. She'll just use the sign. So I want you to notice specifically how she uses both of her hands in coordination with her facial expressions to mean different things. I'm not going to translate everything, just give you a sample of what sign language looks like. We can just move on to the next slide. So this is our little bit about our company. I want to point out we have 21 employees. 2 of them are deaf employees, and we also have 2 full-time interpreters to work with them. We also have 10 contract workers that could come in, and they're also native signers, so deaf people who work with us on our animations and our avatars. I want to talk a little bit about our company's motto. For us, it's really important to not make products that people don't want, not to try to make needs in society. We want to find out what deaf people actually need and what they want, and then try to fill that need. And I think a lot of companies, at least historically, at least in America, I can't talk about it in Korea, but in America, they would really ignore the deaf perspective, and they would just say, okay, here's a product that we make that we think is interesting, you should use it, you should buy it. And they would say this to deaf people, and they would get legislators, people in the government to say, oh, this is great, we'll give them money. But in the end, all the products, they all fail because they don't listen to the deaf perspective. So for us, that's a really important thing. We also have some patents related to our avatar translation technology. And so along the same lines of listening to our deaf users and our deaf employees, we always make sure to use surveys after every project, or as many projects as we can. This was a survey related to the SRT project that I showed you earlier. And the important thing for me, at least, is we can use this to try to understand what we should be developing in the future. We also can recognize that, okay, at least our avatar is working for getting across information. Outside of the survey, they gave us a lot of feedback that maybe, even though it's getting across the message, it's still not quite natural. So those are the things that we can decide we want to work on and keep improving in the future. So let's talk a little bit about some of our key projects. This is what the SRT app would look like. Basically, someone makes a verbal announcement, and there's a speech-to-text module that it goes through, and it converts it to a text. And then the user can click on the text, and it automatically gets translated to sign language. So some deaf people are more comfortable with text, some are more comfortable with sign language. This lets them choose which one they want to use. We had a very similar app for emergency alert messages, and this basically is, I think, used often these days. I think we all get so many corona-related messages, and so deaf people can use this to automatically translate their emergency messages. We've been working on this augmented reality app. There's these emergency devices like AEDs, and they are, do people know what AED is? Right, exactly. So it's a medical device. So these are available in public spaces, and there's little explanations on the device. But the picture on the explanation is not enough. You have to actually read the Korean. So if you don't feel comfortable reading Korean and you can't understand, then you still can't use it. So this is something that's been very important to develop so people can have an understanding of what's actually being told, or so they can actually use the device. And then the feedback that we keep getting is it's frustrating to have an app for every product that we make. So on SRT, if they take the subway, if they want to use SuoLens, they have to use a different app for everything. So we've been working on unifying everything into a single app called Suotong, which you can download at the App Store. I encourage you to check it out. And then we've been working recently with other companies on this barrier-free kiosk, which is The idea is if you have a disability, if you don't, it doesn't matter. Anyone can use this information kiosk. So I'm going to talk a little bit about AI. I think everyone's familiar with this picture. And I think everyone is mostly familiar with what AI is. So I can't actually give you a perfect definition. No one agrees on a perfect definition for AI. But I want to talk a little bit about different types of AI. So machine learning and symbolic AI. Does anyone know symbolic AI, this term? It's not used as often these days, but it refers to, I think the most common examples are game AI, chatbot AI, expert systems. I think many people might know the term expert systems. These are usually hard-coded AI systems. This is very different to what's been popular recently, machine learning. So basically when an AI teaches itself some concepts. I think many of these keywords people might know: supervised training, unsupervised training, gradient descent, reinforcement learning. So our research is mostly about machine translation, specifically neural machine translation, and which is definitely the machine learning side of things. So I think that many people here kind of have a deep understanding of AI, and I only prepared a very general presentation. So if you have more questions about the AI technology that we're using, please feel free to ask me. I want to talk about attention. So attention is something that we've been using in neural machine translation for the past 5 years or so. I'm sure some of you are familiar with attention. Before we started using attention, the problem was when we would translate a sentence, it's sequence-to-sequence translation. So an input sequence, 어제 집에 갔어요. So the AI would look at each word individually, and by the time it got to the end of the sentence, it wouldn't remember what was the beginning of the sentence. So attention is unique because it lets the AI look at every element together at the same time, which has been a huge game changer actually for machine translation. So the standard kind of encoder-decoder model basically takes an input sequence. This is a very common picture I think many of you may have even seen. So it takes an input sequence of words. So this could be a French, this is a French sentence, and each word gets converted into a vector. And so this vector is very important because we call it's a contextual embedding, which means that it doesn't just refer to the word, it refers to the deeper meaning of the word in this context. What does that mean? So, for example, the word 사과 in Korean could mean like apple, 사과 먹었어요. Or 사과 could be 빨리 사과해. Oh, I apologize, right? Very different meaning, but traditionally in AI, they would be encoded the exact same way. And so the AI wouldn't really understand what the difference is between the two. So what's unique here is when we do this contextual embedding, 사과 for apple and 사과 or apologize would be embedded very differently. So it's actually a much more information-rich method. Which means actually on the opposite side, we have to prepare a lot more data to train this type of model. So that's on the encoder side. This contextual embedding gets generated on the encoder side, and then the sequence of vectors gets sent to the decoder. And the decoder is very much like a person speaking. So the decoder kind of interprets the sequence and says, okay, what would the first word be in the target language? I. And then the second word, M, A, student. This very sequential generation. This is important because sign language is not sequential in the same way that spoken language is. 어제 집에 갔어요 is very linear, right? But the examples I gave you in sign language earlier, they don't have this linear aspect. There's always this multi-dimensional aspect. So how do we reconcile using this type of technology with this type of constraint? Well, one of my favorite examples, has anyone heard of music transformer by chance? So one of my favorite examples is this transformer, the same type of technology used to generate musical scores. So we're going to listen to a little sample made by an AI. Maybe not the most beautiful piece, but still very interesting, I think. And one very important thing to notice is that the AI still recognizes patterns. So you can see a cyclical behavior with the music. And this wouldn't be possible without what I explained earlier, looking at the entire sequence together at once. So how can we do this? We can use certain post-processing techniques to actually convert this linear prediction into this multi-dimensional output, which is similar to what they do in the music transformer. So another challenge that we have then is we're an avatar company, so we work in small animation segments, actually. So we have small, one sign animation, another sign animation, and we need to work on the blending between different animations, so this transition from one to the next. And also we want to change the speed of different animations to make it look more natural. And this is actually a challenge that many companies have been working on. Here's an example from Facebook AI for a text-to-speech model. The important thing is the linguistic front end, so most of the language model is handled first. And then on the output of the language model, they can send a copy of it through a prosody model. So it's just a little module you add on the end. So what they can do is use this to output maybe speed or rhythm or other aspects they want to include on the generated voice. And then they can feed all that back into these other modules and generate the voice. And we're using a similar technology in our development for sign language, actually. So let's talk a little bit about avatars. I just have some other avatars from other countries to show you. This is from Japan. NHK is a news organization. On the left is an actual avatar that they use. On the right is an upscaled version of it. I think the upscaled version is very impressive, actually. I was blown away by how high quality this is. Unfortunately, such high quality animations are hard to render in real time, so they usually just use the animation on the left. This is an avatar from Brazil. They made a very interesting design choice to make the head and hands extra large, because those are the most important parts in sign language for expressing different ideas. This is an avatar from Austria. We'll just skip on through. These are some motion capture based avatars. These days, motion capture is being used more and more to make very high quality animations. We actually also use motion capture in developing our animations. Unlike these, where they just motion capture an entire story, we generally motion capture and then slice it down into little bits so that we can piece them together in different translations. There's also been research in sign language annotation and sign language writing being used to create avatars. So this is Hamnosis. This is a system made in Hamburg University for annotating sign language. It's very complicated. So it's not actually like a writing system that anyone, like regular person, could use. These are mostly just for researchers. So to annotate one sign, you have to use many different hand shapes and show where the position of the sign is, where the direction of the sign is, all these different things. But if you specify all that, you could just tell an avatar what to produce. So this has been used recently for sign language animation. Unfortunately, the biggest downside is it's very hard to make natural signs. It's always very jittery and jumpy. These are some examples of avatars in Korea. I think this one on the far right is probably the most commonly seen avatar outside of our company. So you may have seen this before. Okay. So let's talk a little bit more about the solutions that we're using internally. Our first solution that we made is just a basic rule-based translation engine. Not machine learning, this is more like symbolic AI. So we'll get an input sentence that we need to translate. We'll do a bunch of linguistic analysis. And then we have sign language experts and sign linguists come in and they make a bunch of rules. So if this word is followed by this word, then we translate it this way. This word is followed by this word, we translate it this way. So we basically just run the sentence through all of these rules and we generate this sign script. So it's just a linear list of animations, which is okay for getting across information, but it's not going to be great for actually generating realistic, natural signs.
우리는 하나 언니 김수연, 그리고 언니는 수어로 이야기해줄 박성경이라고 해요.
So this is the generated animation from this type of technology. It's okay. Not good enough though. So then what we really want to do is have a general neural machine translation engine that we can use. However, generating enough data is nearly impossible. Giant companies like Google and Naver are able to do this because they have a lot more funding. So this is something that we haven't been able to do until recently. until recently, this has been our main method then, is to use this rule-based translation to translate a sentence, and then we take the output of that translation and we have those same linguists and sign language experts come in and they just hand tune it, and they change it a little bit and a little bit until they make it natural. So they can add additional bisuji or add blending and kind of change the speed of different signs. And so we can make what we call a perfect translation. So we usually call this template translation because these are all just pre-saved that we spend a bunch of time actually translating. I'll come back to this in a little bit. So these are our two solutions currently, is the rule-based solution and rule-based into hand tuning. And so what I've been working on introducing is just, I'd like to say it's more simplified, but within this one step there's a lot of things going on. So just to use basically neural machine translation for a limited domain. We decided to pick weather data and emergency alert data, and we're going to develop with help with TestWorks and several other organizations, 200,000 data instances by the end of this year. And then we are going to train our neural machine neural machine model on this data. So it will be specifically trained only for these two small domains. And this model training project is actually being done with TestWorks, KT, and several other organizations. So you've already heard from KT, they're doing Korean Sign Language to Korean translation. TestWorks is doing very important data processing software. We've been working on the Korean to Korean Sign Language side. KAIST is also involved, but they're doing both directions. Korean Sign Language to Korean and Korean to Korean Sign Language. So we'll be working closely with them to make sure that we all have actually as many resources as we can get. And one thing that's very important to us is to use the Korean Association of the Deaf and make sure that they're involved closely so we can understand Korean deaf perspective. Without, as I mentioned earlier, that's a very important thing for us. We're also working with several overseas organizations, Hamburg University in Germany, DePaul University in Chicago, and the Easier Project, which you probably haven't heard of, but they're actually doing a very similar project with us. Very similar goals of making neural machine translation models from Korean to Korean sign, from European languages to European sign languages. So as I mentioned earlier, this is our general setup, encoder, decoder. I'm not going into too much detail here. Afterwards, feel free to ask me questions. So this is our model overview. It's just input sentence to the encoder to the decoder. The first problem that I haven't talked about yet is jiwa. I mentioned earlier how we have to have this finger spelling. So our solution is to take the output of the decoder. This is the predicted sign. We're going to send it first to the pointer module. So this is a separate module that we add on. And that module kind of analyzes this embedded vector and says, hey, is this a sign that I know? Is this the right sign? If it decides that it's not, then it's going to look back at the output of the encoder. And it's going to choose one of these contextual embeddings that actually should be outputted. So if it chooses this one, we can just trace it back to the original word and just fingerspell the original word. And actually, our tests so far have been pretty promising that this could be an effective method. In my opinion, it's depending very strongly on custom pre-training methods that we're still working out, but it seems like it's going to be working fairly well. A similar problem as earlier I mentioned about speed and blending. We call this in English, we're going to say prosody. And this is similar, we can just add it on at the end as a separate module. And just naturally predict these speed things and send them all to our avatar player, and the player will then create a more natural animation. So this is our current model configuration. In the future, we are working on adding kisuji, these other non-manual signals. And we also want to add more support for signing independently with both hands. We already have some ability to tap into the multi-dimensional and multimodal aspect. But by adding more modules here, and by splitting the decoder into several sub-decoders, we can actually access more of the natural sign language that we want to animate. So, as I mentioned earlier, our AI is only trained on weather data and emergency alert data. So when we get an input sentence, the first thing we need to do is check what type of sentence it is. If it matches one of the I mentioned earlier, fine-tuned templates, we can just use that template, maybe modify it a little bit, and use that animation. If it matches our training data, then we can use our AI that we've trained. If it doesn't match either, then we can always fall back to our rule-based translation, which isn't perfect, but it's a kind of catch-all that can translate anything with an acceptable translation. This is our current hybrid model, as we're calling it, and our current approach to translating Korean to sign language. So I'll give one quick, this is our final slide, I know I'm running a little long. Quick usage scenarios. So as I mentioned earlier, emergency alert messages, our app can send this to our server where it will be translated. Then we'll send the sign language animation packet to the user's phone, and our app will actually play the translation for them. So this can be done seamlessly. We've already had this working without any problem. So one important thing for modern machine learning models, I think most people here know, is that they can be very modularized. Basically, you can have a bunch of different modules, put it together for one giant model, and then fine-tune it end to end, which is so important for us because we have a plan to use the pipeline I mentioned to you earlier. At the front of the pipeline, if we put an inchi module, so recognition module, then we can also do sign language to Korean, and then run it through the exact same pipeline, and then input a translation. So one of the apps that we've been working on applications for this is just asking for directions. So actually there's a similar idea to the presentation we just watched. So they can open up their phone and ask, okay, how do I get to this location? How do I get to the hospital? And then it can be automatically translated, and they receive the translation almost live, almost instantaneously. Similarly, for weather data, it's not actually already in text form, so we would have to do speech-to-text module first, and then we can follow the same pipeline. Our efforts here are really to bridge the gap for deaf people and hearing people for access to information. Deaf people have so many more challenges in the public space for access to information resources. And our company and our partner companies are working really hard to change this, and we hope that this type of pipeline and this type of model can help us achieve our goals. Thank you so much for listening. If you have any questions, feel free to ask. I can try to answer in Korean, or feel free to ask. Any questions? Yes.
Yeah, thanks for the great presentation.
Thank you.
And I have a couple of questions. So one is, so this is kind of very, very ignorant question. So for the when you're translating from the Korean text to the Korean sign language, is there some kind of just like music notes when you have music? You can upload music notes. So is there some kind of different Korean language representation specifically for sign language? Not the real motion, but some kind of the notation, like the braille like notation. Are there such textual representation for sign language?
That's a great question. Actually, I didn't talk about our internal data structure that we're using. So our base unit is actually just pre-made animations. So we, as I mentioned, we do motion capture for animations, and then we try to cut it into as small units as possible. So what we're actually predicting is an animation ID, and then we're predicting additional information to modify that animation to make it blend with the rest of the sentence. So it's basically we're predicting multiple lists of animations, because right hand, left hand, isuji all have to be predicted, and then we predict speed, overlap, blending, changing the position of the signs, all those things. So it's a little, it's not exactly the same as maybe predicting like Hemnosis has all those special notations. It's very much predicting into just like a JSON file, the specific data structure that we're using internally. Does that make sense?
Yeah. So it's there isn't any kind of official, sign language note, but you develop your own representation.
Exactly. So it's
okay.
It's a representation that works only with our player that we've developed internally.
I see. I mean, the reason I'm asking is that if you have such a notation, I'm thinking that you might be able to generate your own data. Because the lack of data, I think that's one of the fundamental problem in this sign language generation. So So if you could have such a representation, you could just generate hundreds millions of data.
That's actually a really good point that we've been thinking along similar lines, and I think our partner companies, we've been talking with them about how to generate data, especially as we do these data generation projects. We've had some ideas about maybe working backwards from, because our avatar, we have those same key points that they use for OpenPose. We've been thinking about maybe just working backwards from those to generate our internal data structure. So you can just film a bunch of people signing and basically freely make this data. But there's still a lot of challenges with that as well, and there's a lot of, I guess, barriers that we'll have to get over to make that work. Right? But that's actually a really good idea that I really want to do as well. Thank you for asking.
One more question.
Oh, sure.
I see the avatar. So I think one of the things that like Chisuji, kind of the aspect is I was wondering how you can express it, because I like superficial understanding of sign languages that your facial expression matters a lot. So the avatar, they look all right now. They all look like motionless and emotionless.
Sure.
So it looks kind of they don't seem to have any kind of emotions. So I was wondering how you can do that.
Sure. So we have, again, thank you for the question. It's a great question. I'm going to go back all the way up. This may take a second, to the beginning of our presentation. Excuse me. It's a long presentation. You guys are very patient. Thank you. So the SRT video I showed you, I just want to show it to you once more and then talk about it. I apologize. Your part. Okay. So as you see here, we actually have some bisuji that go into the facial expression. You can see also that the avatar actually looks at his hands at certain times.
안내 말씀드립니다. 지금 우리 열차 5호차 6
So we can actually put in these bisuji animations. We capture them separately and we hand animate them to make sure that they look accurate. But up until recently, our automatic translation methods didn't use bisuji. You're right. So everything that's hand-tuned, we can incorporate them in just fine, no problem. But in the future, and actually I've been starting incorporating bisuji into the rule-based model as well, until we can get the neural machine translation model working. But in the future, we can actually just predict those on a separate stream the same way we're predicting each hand. So for predicting right-hand signs, left-hand signs, we can also predict facial signs in the exact same way. But you're right, many of the things that you saw today didn't actually have them included yet. So that's something we're going to include more and more in the future. Does that answer your question?
Yes.
Thank you. Are there any other questions?
한국어로 질문하세요.
네, 이렇게
네.
질문하셔도 돼요. 그럼 뭐 나중에 편하게 사진 네네.
그 아바타가 제대로 동작을 했는지 어떻게 판단하죠?
검증 맞나?
네. 그러니까 그러니까 is there any methods to measure the animation pose? Because we can trust the person to move, but the animation, I don't know how can I trust them the right pose or right move.
Thank you for asking in English too. I appreciate that. So that's actually a really important question, and something we've been debating recently internally and also with TestWorks as well. Our avatar has those key points, the same with OpenPose that I mentioned earlier. So one of the solutions that we actually, TestWorks, I mentioned the joint project that we're doing to train these models. One of TestWorks' jobs is to develop, is it okay to talk about TestWorks? it's not my company, so I hesitate a little bit to talk about it. But one of the things that they're developing is this sort of evaluation methodology. So as far as I know, it's going to use some sort of comparison of these key points in our avatar with key points in, when we generate this data, we actually make sure to take a video of every single sample. So we have someone signing for every sample, and we can extract those key points and compare them with our avatars. That's the basic evaluation that we've been thinking of for the future. I think the thing that's a little bit more important, that's a very important quantitative evaluation. A little bit more important is qualitative evaluation, so showing it to actual deaf people and having this kind of human evaluation. So we're also planning on doing that in the future. If you have any other suggestions or things we should do, I would love to hear them. Or any other questions?
I have a question regarding to the transformer architecture. Maybe it also has a problem when adopting the baseline segments on the model. Also, segments for the training model and inferencing model will be different.
Sure.
Regarding this, do you have any strategies for the better contextual understanding or while inferencing or training?
What was the first part of the question? Could you repeat that, please? I'm sorry.
Do you have any difference setting between model training and inferencing step regarding to the segmentation?
Okay, thank you for the question. That's perfect. I mentioned very briefly that we've been experimenting with custom pre-training methods. Originally, what we wanted to do actually was to use kind of public checkpoints, so pre-trained models, and just fine-tune them to our application with Korean to Korean Sign Language. But we've noticed that they fail, especially for this multi-dimensional aspect and for the pointing aspect. In general, it's hard to train those 2 points. And so your first question, actually, right now we don't have any major difference between training and inference. It's a very similar, it's the exact same architecture. Our post-processing is a little bit different, but there's no major differences there. I think our biggest techniques that we've been trying is specialized tasks to train the pointer and to train our encoder-decoder on actually Korean-only tasks first, and then fine-tuning it on Korean to Korean Sign Language tasks. And we're still working on exactly what we'll use, so I hesitate to say. But the main focus there is to train the model on pre-training tasks of extracting important points of, it's not the same as summarization tasks, but it's extracting the important points of a sentence, and also just kind of pre-training the pointer module on Korean to Korean sequences. I could talk with you in more detail maybe a little bit after, but I think pre-training for us is going to be the big key to getting that model to work correctly. Does that answer your question?
I have some for after this session.
Sure, go first. Please feel free to ask me.